Hi students, welcome to Sunil's tutorial. This is Sunil here. Let's start with the remaining part of continuity. We have a last part of continuity remaining. So let's see this. Now, question. They will tell you that f of x is equal to 2x square plus 5 upon x plus 1 x minus 2. Discuss the continuity in minus 2 comma 1. You have to discuss the continuity of this function in minus 2 comma 1. Now let's see how do we do this. Now I can say that f of x is a polynomial. If f of x is a polynomial, that means its denominator should not be equal to 0. If it's a polynomial, its denominator should not be equal to 0. That means the polynomial or the fraction will be continuous for all values of x so long as the denominator is not 0. So let us first find out what are the values of denominator where what are the values of x where the denominator will be 0. Let's see this. Consider x plus 1 into x minus 2 is equal to 0. In that case I can say x is equal to minus 1 or x is equal to 2, right? Now minus 1 belongs to, they've given you the limits as minus 2 to 1. So minus 1 belongs to minus 2 to 1. Very simple guys, minus 1 lies between minus 2 and 1 and 2 does not belong to minus 2 comma 1. Since the values of x are between minus 2 and 1, the value of x is equal to 2 is not going to have any effect on the polynomial. Hence, I can say that f of x is continuous for all values of x in minus 2 comma 1 except when x is equal to minus 1, because if x becomes equal to minus 1, the denominator will become equal to 0 and the fraction will become equal to meaningless. Fine? This is how you solve this sum. Let's see another sum of this kind, guys. F of x is equal to 3x minus 2 sin x upon x squared plus 9 for real values of x. Right? Now I have to check the continuity of this function for real values of x. Again I can say that f of x is a polynomial. A polynomial will be continuous so long as the denominator is not 0. Right? So let us consider that the denominator is 0. If denominator is 0, then I can say x squared is minus 9. Minus 9 can be written as 9 into minus 1. Minus 1, guys, you learned this concept in 11th standard. Minus 1 can be written as I squared. Thus, x is equal to plus minus 3i. Now, so I can say x as plus 3i and minus 3i are imaginary numbers. None of them is a real number. Both of them are imaginary numbers. They contain I. Are imaginary numbers. Right? Therefore, it is very clear from here that the denominator is not going to be 0 for any real values of x, right? X, which is equal to plus minus 3i, does not belong to real values. Therefore, I can say that f of x is continuous in the interval for x belongs to real numbers, right? That's how you would do this sum. Do we get this idea? Let's move on to the next one, guys. f of x is equal to x plus 1 upon x minus 1, where x is greater than 0 and less than 2, is equal to 5x minus 7, where x is greater than 2 and less than 4, is equal to x square plus 5 upon x minus 3, where x is greater than 4 and less than 6. You have to test continuity in the domain. You have to test the continuity of this function in the domain. Now, when you have multiple functions given to you, you have to check only those numbers which are common. Like here you have 2 common and you have 4 common. So you have to check only those numbers for which you have common values of x, because continuity can be checked only at those points. Right? Now if I look between the first and the second equation, the common point is x is equal to 2. So I'll say f of x, limit of f of x as x tends to b, the common point is 2. Let's check for greater than 2. How do I write greater than 2? X is equal to 2 plus. Now x is greater than 2 in the second equation, so I can say limit of x tends to 2, 5x minus 7. There's no need to write the greater than sign in the second on the right hand side. So this is going to be straight away 5 2s are 10 minus 7, which is 3. Now limit of f of x as x tends to less than 2. X is less than 2 in the first equation, so I can say limit of x tends to 2, x plus 1 upon x minus 1. I'm taking the first equation, people. So this will be 2 plus 1 upon 2 minus 1, which is 3. You can say as limit of f of x as x tends to greater than 2 is equal to limit of f of x as x tends to less than 2. Since the two limits are same, therefore f of x is continuous at x is equal to 2. So we have already tested for one common point. Since there are 3 equations, there is another common point. Which is the other common point, guys? The other common point is 4. So now we'll have to test continuity for 4. Limit of f of x as x tends to greater than 4. X is greater than 4 in the third equation, so I'll say limit of x tends to 4, x square plus 5 upon x minus 3. Just write this 5 clearly. X square plus 5 upon x minus 3. This is 16 plus 5. 4 square is 16. I'm directly substituting. 4 minus 3. 16 plus 5. 21 upon 1, which can be written as 21. Now limit of f of x as x tends to less than 4. X tends to 4. X is less than 4 in the second equation. So this is nothing but 5x minus 7. 5 4s are 20 minus 7, which is 13. So I can now say that limit of f of x as x tends to 4 greater than 4 is not equal to limit of f of x as x tends to less than 4. Therefore, I can say that the function f of x is discontinuous at x is equal to 4. Now once you check for continuous points, you have to also make sure that the 3 equations which are given to you, their denominators are not 0. Once you have checked for the continuous points, the next thing that you have to make sure is that the 3 equations which are given to you, their denominator should not be equal to 0. Right? Now consider the first equation. If I consider the first equation where they have given you f of x is x plus 1 upon x minus 1. Right? If I consider the first equation where they have given you x is greater than 0 and less than 2. Right? Now if I make the denominator 0, when will the denominator be 0? When x is equal to 1. So if x becomes equal to 1, 1 minus 1 is 0, then x minus 1 will become equal to 0. That means the denominator will become equal to 0. That means the function will become discontinuous. Moreover, x is equal to 1 belongs to 0, 2. It belongs to this interval. That means the function will be discontinuous. F of x is discontinuous at x is equal to 1. Fortunately for us, the second equation does not have a denominator. Let's consider the third equation. Consider f of x is equal to x square plus 5 upon x minus 3 as x is greater than 4 and less than 6. Okay. Now, I can say that if the denominator becomes equal to 3, that means if x becomes equal to 3, the denominator will be 0. If x is equal to 3, then x minus 3 will become equal to 0. But x is equal to 3 does not belong to 4, 6. Therefore, it will not have any impact on continuity. Hence, your final answer, we'll write this here. I can say that the function f of x is continuous in the domain. How do I find out the domain? Guys, can you please see here? How do I find out the domain? The domain is the smallest number here and the largest number here. The domain is the smallest number here and the largest number here. Is continuous in the domain 0, 6 for all points except when x is equal to, we have already proved that it is discontinuous at x is equal to 4 and x is equal to 1. So for these 2 points it is going to be discontinuous, otherwise the function is going to be continuous. Do we get this thing clear? Let's try another sum of this kind, guys. F of x is equal to minus 2 sin x, where x is greater than minus pi and less than equal to pi by 2, minus pi by 2 is equal to alpha sin x plus beta, where x is greater than minus pi by 2 and less than pi by 2 is equal to cos x when x is greater than pi by 2 and less than pi. You have to find out alpha and beta. You have to find out alpha and beta. Let's see how do we do this. Now, I can say that as I explained to you in the previous sum, you have to see for common points. Right? Do we get this thing clear? You have to check the continuity at common points. So let's see this. Now the first common point that you have is minus pi by 2. So you will say limit of f of x as x tends to be minus pi by 2 greater. Now x is greater than minus pi by 2 in the second equation. So you will write limit of x tends to minus pi by 2 alpha sin x plus beta. Substitute the values. So this is alpha sin minus pi by 2 plus beta. Minus pi by 2 is 270. Sin 270 is minus 1. So this is minus alpha plus beta. Similarly, limit of f of x as x tends to be minus pi by 2 less than. Right? Now x is less than minus pi by 2 in the first equation. So limit of x tends to minus pi by 2 minus 2 sine x. So this is minus 2 sine minus pi by 2. Minus pi by 2 is 270 degrees. Sine 270 is minus 1. So this is going to be minus 2 into minus 1. So which is 2. They have given you that, guys, can you please see this? They have given you that find alpha and beta if function is continuous. Now you will say that as function is continuous, if the function is continuous, that means limit of f of x as x tends to be greater than minus pi by 2 is equal to limit of f of x as x tends to be less than minus pi by 2. We have found out the two values as minus alpha plus beta is equal to 2. Call this as equation 1 and leave it as it is. Now the other common point that you have, guys, the other common point that you have is pi by 2. You have already checked for minus pi by 2. The other common point that you will check for is going to be pi by 2. So now limit of f of x as x tends to be greater than pi by 2. Now x is greater than pi by 2 in the third equation. So this will be limit of x tends to pi by 2 cos x. This is going to be nothing but cos pi by 2. Cos 90 is 0. Right, do we get this thing clear? Next, limit of f of x as x tends to be less than pi by 2 is limit of x tends to pi by 2. Now it is less than pi by 2. X is less than pi by 2 in the second equation. So alpha sine x plus beta. Sine 90 is 1. Alpha sine pi by 2 plus beta. Sine 90 is 1. So this is alpha plus beta. You will say as function is continuous, I can say that limit of f of x as x tends to be greater than pi by 2 is equal to limit of f of x as x tends to be less than pi by 2. That means I can therefore say that alpha plus beta is 0. Call this as equation 2. Solve equation 1 and 2 simultaneously. Solve equation 1 and 2 simultaneously. If I solve equation 1 and 2 simultaneously, I will get 2 beta is equal to 2. Therefore, beta is 1. Substitute the value of beta in any one of the equation. Let's assume I substituted in equation 2. We just continue on the right hand side. Substitute beta in equation 2. If I substitute it in equation 2, alpha plus beta is 0, alpha plus 1 is 0. Therefore, I can say alpha is minus 1. So thus we have found out the value of alpha and beta. This finishes this chapter continuity. Thank you very much.